Welcome to today's video where I'm going to continue our discussion on trigonometry. We're going to look at what are referred to as special angles. Special angles are angles that we can work through using their trigonometric ratios, but we will not need to use calculators. So based on the fact that trigonometry is a fairly old branch of mathematics, that existed long before the arrival of calculators on the scene. There must have been ways that mathematicians were able to navigate through trigonometry without relying upon a calculator like we do in this day and age. So we will start with looking at angles that are associated with 30 and 60 degrees. So there's going to be a couple of diagrams here that you're going to need to make sure you memorize at the end of things. I will show you where they come from, but ultimately, when all is said and done, there are 3 diagrams that you're going to need to know and be able to quickly sketch on an as-needed basis as you're doing some trig questions. Alright, so if I start out here with this diagram down below. So put yourself back in the days of no calculators were existing. So we're sitting here, we don't have a calculator, and we're going to try and make some trig ratios. So what the first triangle they would have made was a triangle that they could guarantee the angles were all 60 degrees in. So they made one side 2, made the other side 2. Well, this other side, if it were also a 2, then you've got an equilateral triangle. And an equilateral triangle, all angles and all sides are the same length. So that would have to also be 60 degrees. Then what would have happened is they would have drawn in what they call an altitude. So I'm going to erase this 60-degree angle now, because from up here I'm going to draw down an altitude. So an altitude is a line that goes from a vertex and it meets the opposite side of a triangle at a 90-degree angle, like you see here. In an equilateral triangle, the good news is it does a couple of other things besides meet this side at a right angle. It also bisects it, and it also bisects this angle. So this angle that used to be 60 is now 30 and 30. And these two pieces down here are 1 and 1. Then what we're going to do is, because we've created a right angle, let's take this triangle here. So I'm just going to kind of cut a piece of this out. So we're only going to use this triangle right here. And this is what it would look like when you bring that out and have a look at it. So it's going to be got your right angle. So this piece is 1, this piece is 2, that piece I don't really know right now, but I do know that this angle is 60 and this angle is 30. So let's assume that we don't know any trigonometry or any trig ratios yet. We don't have calculator at our disposal. We should be able to determine the length of this side without any of those devices. We're just going to use Pythagoras Theorem. So let's suppose we call it I don't know, x for now, I guess. So x squared plus 1 squared would have to equal the hypotenuse squared. So x squared would have to equal 4 minus 1. X squared is 3. X is the square root of 3. So this side, which I now know, this side is actually now the square root of 3. Well, guess what? Because this is a right angle triangle, your right angle being down here, we could now identify whether it was, if I use 60 degrees, and I said, what's the sine of 60? I can look at this triangle that I've just created and say that because that's a right angle, the sine of 60 is the opposite over the hypotenuse, radical 3 over 2. Someone says, oh, what's the cosine of 60? The cosine of 60 is 1 over 2. Notice we're not using a calculator. The tangent of 60 is opposite over adjacent, radical 3 over 1. And then, of course, if you needed the reciprocal ratios, you could flip each of these over. So cosecant would be 2 over root 3. Secant would be 2 over 1. tangent would be 1 over root 3. If you needed trig ratios for 30, so let's say I wanted the sine of 30 instead of 60, well, the sine of 30 for my triangle is 1/2. The cosine of 30, so again, I'm just looking at this angle now instead. The cosine of 30 is radical 3 over 2. And the tangent of 30 degrees is 1 over radical 3. So I'm now able to get the trigonometric ratios that go along with 60 degrees or 30 degrees as long as I can sketch this triangle. So, having said that, I showed you where it came from. You need to study and memorize this triangle. If you don't know this diagram, you're not going to be able to succeed in this section on special angles. So there's your first diagram you now need to know. The next diagram we're going to look at is when we have a 45-degree angle. So we want to be able to get the trig ratios of 45 degrees without using a calculator. Well, if I start with a right angle triangle and an isosceles right triangle, meaning these two sides are going to be the same length. So I'm going to pick 1 and 1. Now, let's figure out this number here using Pythagoras Theorem. So Pythagoras Theorem would say that r squared is 1 squared plus 1 squared, which is 2. So r must be the square root of 2. So this side up here, we now don't need a variable for it because we know how long it is. This side is the square root of 2. And now we have something similar to what we just had. We have a triangle that we're going to be familiar with eventually, hopefully. You are anyway. That looks like this. I don't know why I'm redrawing it, but I will. 1, 1, radical 2, and you've got a 45-degree angle in either corner, doesn't matter, which would allow you now to state the trig ratios of 45 degrees without touching a button on a calculator. Your right angle is here. The sine of 45 is 1 over root 2. Cosine of 45, 1 over root 2. Tangent of 45 equals 1 over 1. Just in case you ever make your way onto the Jeopardy game show, here's a question for you. It's the only angle in existence where the sine of the angle and the cosine of the angle are the exact same thing. It's the only angle that ever happens with, or some angle that's coterminal with it on a rotation system. Okay, so there's your second diagram you need to know. So this diagram will let you get trig ratios that are associated with a 45-degree angle. So right now, we've got 30 covered, we've got 60 covered, and now we've got 45 covered. So if someone says, what are special angles? The first three special angles are 30, 60, and 45, and they coincide with those two diagrams that we've just looked at. All right, so now if I want to look at what are referred to as quadrantal angles. Quadrantal angles is a mathematical term for an angle whose terminal arm lies right on a quadrant boundary. So for example, this angle right here is 0 degrees or 360 degrees. Its terminal arm is laying right on the x-axis. We have another angle up here. That's 90 degrees. Its terminal arm is right on the y-axis. Another angle running across here. Oops. Terminal arm is right on the negative x-axis, and then you have another angle that runs down here, whose terminal arm would be on the negative y-axis. Now, to navigate this, we're not using triangles on this system. We're going to use something referred to as the unit circle. Hopefully, somewhere along the way you've heard tell of unit price. That means the price for one. The reason they call this the unit circle, it's a circle that's got its center at the origin. And if you notice these 4 points, 1, 0, 0, 1, negative 1, 0, and 0, negative 1, it's going to give us a radius. No matter where on this circle, the radius of the circle is always going to be 1. Now, remember here, when we're drawing this, when we did reference triangles and their trig ratios, you had your x here, your y here, and we always call this line r. And r is in our trig ratio here. Well, the problem is when you get to up here, you can't make reference triangles. However, these trig ratios don't change. They still are equivalent to the y coordinate divided by the r value, the x coordinate divided by the r value. Now, having said that then, on this diagram, r everywhere is equal to 1. Now, what this would allow me to do is, let's suppose I needed the cosine of 180 degrees. So I need to know this chart and say, okay, cosine is the x over the r. So I go over here to 180, and I say, what is the x coordinate associated with 180 degrees? It's a -1. What's the r value? It's always 1. Therefore, the cosine of 180 is -1. What if I said, okay, what about the sine ratio? Oops, let's do 180 again. So the sine of 180 degrees, all right, so the sine of 180 degrees is the y value divided by the r value, so y over r. Well, at this particular spot on a graph, on a rotation, the y value is 0, the r value is 1, so 0 over 1 is equal to 0. So the sine of 180 degrees is 0. Notice I'm not touching any calculators. I'm just doing this by reasoning and knowing which coordinate over what gives me each particular trig ratio. Well, let's see if we can make sense of something like this. If I, on the unit circle, actually now, oops, that backwards. So on the unit circle, anywhere you pick, at one of these quadrantal spots, so whether it's there, 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 or there, maybe I'll go down here where I have more room. This point, the ordered pair, which is normally x, comma, y, I'm going to tell you that that ordered pair is now sine theta, comma, cosine theta. And the reason it is because sine of theta is x over r. But r, if you are using the unit circle, the r value is always 1. So it doesn't matter whatever you put in here for x, because the number on the bottom is a 1, the x value is going to be the cosine value. Right? So if r is, think about this, if r is 1, x over 1 is just x. Sine of theta, y over 1 is just y. So the y coordinate becomes your sine ratio if r is 1. The x coordinate becomes your cosine ratio if r is 1. On this diagram, r is always 1. So therefore, these ordered pairs, the first number, the x, is cos. The second number, y, remember y, sounds like psi, y, is your sine ratio. So if I start my way around the unit circle and I say, okay, at 0, position 0, cosine is 1, sine is 0. Now the tangent is the y divided by the x. So 0 over 1 would be 0. Let's go up here. Scroll up a bit. Okay, so cosine is the x. So cosine is 0, sine is 1, tangent is 1 over 0, undefined. If you're sitting there with a calculator nearby, type in the tan of 90. Guaranteed your calculator is going to say error. That's why. Because what it's trying to do is divide the y coordinate, which is 1, by the x coordinate, which is 0. And we know from our past experience with numbers and divisions, you cannot divide by 0. So that's why the tangent of 90 is undefined. All right, we're at 180. Cosine, -1. Sine, 0. Tangent, 0 over -1, which would be equal to 0. Let's come down here. 270. So the cosine is 0. The sine is -1. The tangent, -1 over 0. It would also be undefined. And then you're back to where you started. Now, imagine if you flip these over. So it's 1 over. So now, you got to watch for these, because now some of these ratios can go undefined. Because if here it was no issue, there was always a 1 on the bottom, you might have had a 0 over 1. But now you might get 1 over 0. And if you get 1 over 0, that's undefined. So what you need to do when you go around to do your reciprocal ratios is when you get to the x value, you need to take its reciprocal to get secant. When you get to the y value, you need to take its reciprocal to get the cosecant value. And the tangent, you need to divide the x over the y instead of the y over the x. Now, if you have the number 1, which is equivalent to 1 over 1, and you took its reciprocal, well, it's still 1, so it's not going to make any difference. If you had negative 1 over 1, and you took its reciprocal, you're still going to get negative 1. So the reciprocal of 1 is still 1. The reciprocal of negative 1 is negative 1. Here's the tricky one. The only way you ever get 0 is if you have 0 over 1. Well, then when you take the reciprocal of 0, it would end up 1 over 0, which is undefined. Okay, so let's go around the unit circle again. This time I'm going to do reciprocal ratios. So I need to know that secant goes with x because it's the reciprocal of cosine. Cosecant goes with y because it's the reciprocal of sine. And cotangent is the reciprocal of tangent. So I'm going to flip it and do x over y. Here we go. If I was trying to get the secant of 0, secant, I take the reciprocal of the x. Well, the reciprocal of 1 is still 1, so the secant of 0 is 1. However, the cosecant, the y value is 0. If I try to take the reciprocal of 0, it goes undefined. So therefore, the cosecant of 0 degrees would be undefined. The cotangent, which is the x, being 1, divided by the y, which is 0. If I tried to divide 1 by 0, undefined. Up to here. Secant, my x is 0. I can't take the reciprocal of 0, so secant of 90 is undefined. The cosecant of 90 would be 1. The cotangent is 0 over 1, which is fine. That equals 0. At 180, negative 1. So secant would be negative 1. Cosecant would be undefined. Tangent, or sorry, I keep saying tangent. Cotangent, which is the x over the y, would also be undefined. 270. So my x is 0, so that means secant is undefined. Cosecant would be negative 1. Cotangent, 0 over negative 1, that would be 0. And then I'm back to here. So that is how we use this diagram, the unit circle, to navigate and figure out trig ratios of angles that end up right on these quadrant boundaries. Okay, so from these past few slides, these are the 3 diagrams here that you need to know. So it's not, so students say, oh, I'll say, what does the triangle look like for 30 and 60? Someone say, well, I don't know. Well, I can't help you. You have to study these and make sure you know them. Then you also have to study and make sure you know these 6 trig ratios. So what you see on this slide, if you don't know it by memory and you aren't able to draw and generate these on your own, that's where you start. You need to know these. Okay, so I'm going to put these to work now and show you how we use them. So the first type of question would be something like this. Let's suppose I wanted to find the tangent of 240 degrees. Well, we're going to go back to now our discussion on the last video about reference diagrams. So we're going to do angles that aren't going to be, it's not going to say necessarily 30 or 60 or 45, but when you draw your reference triangle, like we're going to do this one, if that's 240, this little angle in the corner, the reference angle, is always going to turn out, it's going to turn out to be one of one of our special angles. So in this case, that little angle is 60. Now, this is where I need to know my diagrams. So you're going to draw a lot of these triangles over the next little bit. So you're going to get good at them if you're doing any practice at all. So I should backtrack here for a second. Just one little thing that I find students will mix this diagram up. Here's a way I'll try and help you so you don't screw up the sides. This one no one usually screws up. I do find sometimes they'll put 2 here instead of root 2. Remember, it's this squared plus this squared. Take the square root of the sum of those, you'll get this one. On this diagram, the way a triangle works is, if you see here you've got 60 degrees and 30 degrees, and then you got a 90-degree angle. And your 3 numbers are 1, 2, and the square root of 3. Well, the square root of 3 is 1 point, I don't know, I think it's 1.7, something like that. It's somewhere between 1 and 2. So 2 is the biggest, 1's the smallest, and square root 3 is in between those two. Here's a property of triangles that you may or may not already know. Across from the smallest angle in any triangle is always the smallest side. So if you have a 30-degree angle here, which is the smallest of these 3 angles, the smallest of the 3 sides has to be across from it. Here's your biggest angle, 90 degrees. Across from it must be the biggest side. 60 is your second biggest angle. It would have to have the second biggest side across from it. That's a way to maybe not screw up what number goes in across from which angle. Okay, so back to here. So I'm trying to put the numbers on this triangle that go with 60 degrees. So across from a 60-degree angle is always the square root of 3. This is your 30 now down here in the corner, so across from it is 1. And then this is your hypotenuse, so it's 2. But what you can't lose sight of is now we're on the Cartesian plane, so you got to pay attention to negatives. Over here are negative x's. Down here are negative y's. Recall that the hypotenuse, or the r, we always put it as positive. Now if I want the tangent of 240 degrees, I read it off of this little triangle. So the tangent of 240 will be the opposite over the adjacent. So that will be radical 3. I'll show it everything. So it's negative radical 3 over negative 1, which is equivalent to just the square root of 3. Okay, next one. 135. So I make my reference triangle, always down to the x-axis. If that's 135, so that's 90 plus 45, that means this little angle is 45, one of our special angles. Across from the 45s are 1 and 1. Hypotenuse is radical 2. These are negative x's, these are positive y's. I want the cosine of this particular angle, so the cosine will be adjacent over hypotenuse. There's the cosine of 135 degrees without using a calculator. 270 degrees. So 270 ends up right here. So what I do with these ones, you don't make a triangle, you put a dot. And you say, what would be the coordinates of this point? Imagine, you don't have to, you can physically draw it in if you want, but imagine there was that circle that we had on that first one, the unit circle that had a radius of 1. This ordered pair would have been, x would have been 0, and the y would have been negative 1. I'm looking for the cosine. Cosine, our brains need to say they want the x-coordinate. So the x-coordinate here is 0. Therefore, the cosine of 270 is 0. 90 degrees. 90 degrees puts me up here. So imagine you had a circle, center of the origin with a radius of 1. This ordered pair would be 0, comma 1. Psi goes with y. The y value here is 1. So the sine of 90 degrees is 1. All right, so that's how you can use your special angles to determine the trig ratios of rotation angles, because your reference angle in the corner, if it's one of your special angles, you'll be able to turn it into one of those diagrams that I showed you on the previous slide that you have to make sure you know. Now obviously you can see why you need to know those diagrams, I hope. Okay, so let's say I had 240. I already did that one actually. Yeah, I don't know if I had sine. Let's do it out again just in case. So 240 from scratch, I would just draw this. 180 plus 60 more. Make my triangle. Across from 60 is always radical 3. Hypotenuse in this diagram is 2. That's your 1. These are negatives. These are negatives. So the sine would be negative radical 3 over 2. Look at that. Sine of 240, never touched a button on a calculator. I don't think I want to get into that yet. We talked a little bit about that the other day. Okay, I want to move on to ones like this. So where I give you multiple angles and we do it kind of as an expression. So what you're going to do is you're going to draw a separate diagram for each one of these angles. First thing I got to talk about is when you have a squared on a trig ratio written like this. So sine squared of 60 degrees. This means the trig ratio is squared, not the angle. So it means the sine of 60 degrees, get the answer, and then square your answer. Okay, so I'm going to draw a 60-degree angle. So I'm going to go here, here. So 60 would be roughly here somewhere. Make your reference angle. That's 60. Remember, across from 60 is radical 3. This is 1. This is 2. This is just a diagram you need to have memorized. I'm just going to draw the diagrams for each one. 30. 30. So it doesn't go up quite as far. So the little angle down here is now 30. Across from 30 is always 1. Your hypotenuse is 2. Across from your 60, which is up here, is radical 3. 45. 45. So 45 would end up here. This little angle is 45. So the triangle that goes with 45 is 1, 1, and the square root of 2. And then 180. Down here, 180, you start and you end right here. So it's right on an axis. Remember the name for that is quadrantal. So the ordered pair that would go there on the unit circle, x would have to be -1 and the y value would be 0. Now, looking at each of these, we just fill in our trig ratios. So I'm just going to put an equal sign here and I'm going to do this one. So the sine of 60, go to your diagram, sine of 60 is radical 3 over 2. Now this wants you to square that after you find it. So there's the sine of 60, and we're going to square it. Take away. Cosecant of 30. So here's 30. Cosecant is the reciprocal of sine. So cosecant would be hypotenuse over opposite. So that would be 2 over 1. Secant of 45. So the secant of 45 is the reciprocal of cosine. So secant is hypotenuse over adjacent. And this one also wants us to square it. And then the secant, remember secant goes with cos. So we're talking about the x coordinate. This is a quadrantal angle. So we're going to go to our diagram and we're going to take the reciprocal of the x value. The x value is a -1. The reciprocal of -1 is still -1. Now at this point, trigonometry is done and finished with. Now it's a matter of simplifying. So you're not allowed to use calculators to do these questions at any point. So you're going to square this to give you 3 over 4 minus, you got 2. When you square the square root of 2, you get 2 plus a -1, so that's -1. So I've got 3/4. Take away 4, take away 1, 3/4. Take away 5, that's 5. Now 5 over 1 would be 20 over 4. I want to get a common denominator, so we're going to subtract 20 over 4. There's the value of that expression without touching a button on a calculator. Alrighty. Let's have a look. So this one's got 3 angles I need to be concerned with. 720, -315, and 840. I will clarify, the only thing I'll let you use a calculator for is to find the principal angle. If these ones aren't too bad, but if these angles get really big, and you want to divide by 360, all that good stuff to figure out where the angle is, you are allowed to use your calculator for that. After that, no calculator. Okay, so 720, I'll just sketch it right here. So 720 is 1, 360, 720 is right here. That's the ordered pair 1, 0, quadrantal. -315, so -315. Start here and go this way, so -180, -270, and then another 45. So there's -315, which makes the only angle that really matters is this one, between the terminal arm and the x-axis. Make your triangle, 1, 1, square root of 2. 840. So 360, 720. So I need to go another 120 degrees. So there's 90, and I go 30 beyond that. Now this little angle is 30, which means the one I'm more concerned about down here is 60. So this is 840. Across from 60 is square root 3. This is your 90. Across from it is always 2. This would be a 30 up here. This would be 1. Okay, let's go to our trig ratios and fill in what they ask for. Secant. Secant is reciprocal of cosine, so that it means take the x, and it's a reciprocal ratio, so take the reciprocal of the x coordinate. The x coordinate at 720 is 1. The reciprocal of 1 is still 1. We're going to square it. Still going to be 1. 3. Now I need, so that 3 is just this number, rewrite it. Now do your trig ratio. Sine of negative 315. Look at your diagram. So the sine ratio here would be the opposite over the hypotenuse, which in quadrant 1 turns out to be 1 over radical 2. Last one, minus cosine. So cosine off of this diagram. Oh, I forgot my negatives here, sorry. This is a negative 1, and these are positive y's. So cosine would be negative 1/2. That is a really common mistake. Is students and teachers, like myself, they will forget to put the negatives on your x and y here appropriately, depending on where you draw them. Don't forget that, please. Okay, so now we've got to simplify this, no calculator. So 1 squared is 1. 3 times 1 over 2 is 3 over square root 2. Negative, negative, so that's plus 1/2. I've got a 1 here, so the common denominator of these three fractions would be 2 radical 2. This one I'd have to multiply by 2 radical 2. This one just by 2. This one just by radical 2. 2 like radicals, so 3 radical 2 plus 6 over 2 radical 2. We should get in, I know I kind of ignored it a bit earlier, but we should at this point pay attention to simplifying radicals properly. We at this point now know in pre-calc 12 we should never leave a radical in the bottom of a fraction. So I'm going to rationalize the denominator by doing this. So now the radical 2 needs to multiply into both of these. So it's going to be 3 radical 2 by radical 2. Well, the square root of 2 times the square root of 2 is 2. Times that 3, I'm going to get 6. Plus 6 square root 2. Square root 2 times square root 2 is 2. Times that 2 is 4. And then I notice that this coefficient, and my denominator are all divisible by 2. Here is the final reduced answer, 3 plus 3 radical 2 over 2. So, as I've mentioned before, sometimes students will stop here, right, at this one, which is correct. It's just not in reduced form. It still has a radical in the bottom. They'll then maybe flip to an answer key and see this, and because they don't see that whole rationalizing the denominator process, or they forget about it, they may think they did it wrong. But this answer, put it in a calculator. This answer, put it in a calculator. They're the same thing. Okay, let's do one more of those. And then hopefully this will be enough for you to see how these work. So 315. Let's sketch 315. 315 is 270 plus another 45. You can draw nice big diagrams here, by the way. So 45. This would be 1. 1. Square root 2. Now this time I won't forget. These are negative y's, positive x's. So that one's positive, that one's negative. A negative 210. So we're going to go this way. 180 plus 30 more. So it's up that way. This little angle in the corner is 30. Make my right angle. So that means this is 60. So this is 2. Across from 30 is always 1. Across from 60 is radical 3. Negative x's, positive y's. 585. Well, 360. So then I need another 225. So 180 and 45. So I'd be down here. Got my right angle. That's 45. 1, 1. Square root 2. That's from our memorized triangle. That's negative, and that's negative. There's 585. negative 450. Negative 360, full turn. Another 90 puts me down here. So down here on a unit circle, your ordered pair would be x is 0 and y is negative 1. Alrighty, let's have a look at our trig ratio. So the first one I'm doing is the secant of 315. So that's this diagram. Secant's the reciprocal of cosine, so that would be radical 2 over 1. Now notice that it's squared. So it's positive radical 2 over 1, which is just radical 2 squared. Subtract the sine of negative 210. So sine of this diagram is opposite over hypotenuse. That is 1 over 2. Plus twice cotangent squared. So from this diagram, cotangent would be x, or adjacent over opposite, x over y. Negative 1 over negative 1, that's equal to 1. There's your cotangent, and that one was squared. And finally, the sine of negative 450. So here's negative 450. Psi, y, correct? Psi, y. So you're looking for the y value. The y value is negative 1. Done with your trig. Now show me you know how to do some basic simplifying of numeric expressions. Radical 2 squared is 2. Take away 1/2. 1 squared is 1 times, you gotta make sure you follow order of operations. So square this first to get your 1. Times 2 is 2 times negative 1. That's a negative 2. Look how easy this works out. 2, negative 2, those are gone. Final answer, negative 1/2. Now in an ideal world, I'd love for you to be able to, when you're done, especially those of you with on-screen typing, type this expression exactly into your calculator and see if you can get it to equal the answer that you got, negative 1 over 2. It's a good exercise in data entry. Again, I'm not going to go over that, but it's not easy to do. These ones are easy. Your sine, because you have buttons for these ones. I'll just do one. Let's say you had to type this in, the secant of 315. Well, there's no secant button on a calculator, so what you'd have to type in on your calculator is cosine of 315. You'd have to take the reciprocal of it after you get the cosine of 315, so make sure you close the bracket. That'll do secant of 315, but then you'd have to put another bracket around it and square it. So you'd have to type this into your calculator to do the secant of 315 squared. Again, this one would be easy. Just type it in exactly like you see with the brackets. Same thing when you get into here, so you'd have to go plus and then 2. When you do cotangent of 585, because there's no cotangent button, you'd have to type in tangent 585, put it in brackets to the negative 1. That'll switch it to cotangent. Then put another bracket around that, squaring it to square that. Now, again, I do recommend you try, so pick this one as an example. And it might take you 2 or 3 tries. Type that into your calculator all at once, hit equals, and see if you can get negative 0.5. Alright, so that is our look at special angles in degrees. We will have to do that again, where we, instead of using degree angles, we'll do it in radians, but essentially it's the same thing. It's just switching this to pi over 4 and pi over 3 and pi over 6, but it's pretty much the exact same thing. Okay, so that's what we'll do in this video. We'll end at our special angles, so 30, 60, 45, and any angle that is quadrantal, meaning ends up right on a quadrant boundary. You should now be able to get its trig ratio without using a calculator. So there'll be some practice questions to follow. If you have any questions, as always, reach out and I'll do what I can to try and help you out. Thank you.